morning. My name is Anthony Doherty, and this is the 8864 Data Controller Best Practices presentation. I'm a senior product engineer here at Environmental Systems Corporation, and there's a picture of me with my office and my digital avatar, since so many things are happening online these days. That way you can recognize me when you're online. So first off, presenting your presenter. Again, my name is Anthony Doherty. I have a PE in computer engineering. I've been doing engineering and software development at DSC for over 10 years now, and I'm currently working on the 8864, both the software and hardware aspects of 8864. There's my contact information. I'll put this up again at the end of the presentation. If you have questions as we're going along through this presentation, you can type them in. I'll give a little pause as we go. I have a lot of material to cover in this presentation. A lot of it is going to be considered more as reference material for you to come back and look at a later time. So I'm not going to sit here and read all of the information on all the slides to you, but it will be in the slide deck that we can make available to you after the presentation so you can come back and use it as reference. However, I will stop for questions as we go. And if I miss your question and I've moved on to the next slide, I'll come back to it and we'll get the questions at the end. I promise I won't leave you with any questions unanswered. Again, my contact information is there. If there's a topic that I go over that you want to go into more in depth, please feel free to email me or give me a call. We can try to set up a time where I can work with you to talk about some of the things related to Data Controller, or if you just have some ideas you want to discuss, I'm the guy to talk to. And I'd love to hear any feedback that you have, and we can have those sort of discussions at your convenience. And so that contact information there will be available again at the end of the presentation. So let's talk about what this presentation is about. So we're going to talk about some flags, what they mean and how they affect the data. And this is all 8864 Data Controller. We're going to talk about channel types. What channel types do you really need? And we're going to talk about communications and how to troubleshoot communications issues with the 8864 Data Controller. So that having been said, let's jump into some of the more dense material. Again, for reference, some of the different places where you can find some of the material that I'm going to discuss in this presentation if you want to dig in even deeper. A couple of these are actually internal. The engineering SharePoint site and our M-Files are internal only resources that we use, but you can have access to all these other 8864 manual, StackVision user guide, StackStudio user guide. These are all resources that are available to you on our website. I highly recommend you take advantage of them. Tips and tricks. So as we go through this presentation, if you see this icon, this is a tip and trick slide where I'm going to give you a little bit additional information that may or may not be documented in our documentation resources. This is something that has come about from knowledge and experience in time working with the Data Controller directly. So when you see this icon, this is what you want to look for material that may not be actually documented in the resources I was showing before. So be on the lookout for that. So let's talk about flags. Let's jump right into it. So flags on channels, this is kind of a brief overview, and there'll be some more overviews of these as well. As you can see, just from this quick look, there are a lot of different flags that go on a channel. And because there are so many, it represents a lot of information. Now, some of these flags represent actually validity. Some of these flags represent purely just information. And some of these flags are time-based. Some of them only appear on intervals that are stored and recorded, whereas some of them appear both on instantaneous data and on intervals that are stored and recorded. I'm going to talk a little bit about each of those and what that means as we go along here. First, I'd like to make a quick note, though, about flags versus masks. The Data Controller and StackVision have different methods for applying data quality information. The Data Controller uses what are called flags. B, M, F, et cetera. You've all seen these on your data. If you've looked in Data Lab and looked at the flags tab, or looked on the data controller front panel screen and seen a channel with its value and its flags there. StackVision applies what are called masks. And these are the tags that you would see in Data Lab, for example. When you open Data Lab and you pull in your missing and invalid field. What happens in the data controller is that flags actually do represent instantaneous validity. And those instantaneous validities are summed up and put onto intervals to give them validity. Now, a lot of the material I'm going to cover here, I'm going to go in pretty in depth in some places, and I'm going to make some assumptions about the knowledge that you have of the data controller. And if I lose you at some point, please feel free to reach out to me and I'll help clarify anything that I talk about, or just use this presentation as a reference material later on. But when you're looking at instantaneous data in the data controller, you'll have these flags that represent validity that can affect the validity of intervals that are stored in the data controller. Now, the data controller will only store flags on these data. When these flags are pulled over to StackVision, when StackVision reaches out to the data controller and says, give me the data, and the data is pulled into StackVision, at that point, the flags are interpreted by StackVision, and the masks such as missing, invalid, exceedance, etc., are applied there in the StackVision database. Those are not applied in the data controller. That way, you can always have a record of how the data was recorded by the data controller when it was captured. And later on, you can go into your StackVision database and add these additional masks based on the data, or if you know there was an event that caused some missing or invalid data, you can go mark that data. And those masks are what affect what goes into your Part 75 EDR generation, and also a lot of your Part 60 reporting, exceedance marking and invalid marking for your downtime reports. And those masks help StackVision to report the data out. And it's an important distinction that I like to make between flags and masks, because when you start getting into Data Lab working with data, most of what you're dealing with when you're clicking those check boxes are masks. You're not changing flags. Flags are what exists down at the data controller level. Sort of you can think of it as the raw capture of the data. Masks are what are applied to the data after the fact to get it ready for reporting. So instantaneous validation flags in the data controller. I'm not going to read this to you. I'll let you come back to look at this. Let's talk about instantaneous validation flags. They're shown here. These are all the different flags that in the data controller will cause data to be invalid. And these are instantaneous flags, which means these are statuses that appear on a channel, for example, instantaneously. In real time, every scan that the data controller does of a value, let's say an analog input signal, it will also have some corresponding input signals that represent the quality of that data coming from the analyzer. So the analyzer will be sending out a 4 to 20 milliamp signal and some digitals. And the 4 to 20 milliamp signal represents the value, represents how much is being measured. And the digital signals represent the quality, if the data is good or not. And those digital signals can be assigned to things like bad status. That way, if the digital signal comes in, the analyzer knows something's wrong, it can send a signal to the data controller to say, hey, this is bad data. And so every scan, it'll be marking that data invalid. Later on, when it uses those scans to build a base average, an interval that will be stored, one of these two flags will be applied, either the greater than or the less than. Greater than meaning that there was some missing data, less than meaning that there was not enough data for a valid average. This gets into a discussion about validity, which is an entire presentation all by itself. I leave it to look at some other presentations or some of the resources that I mentioned earlier to get into more details about that. In general, the flags that you see over here are instantaneous. Flags that you see on this side are on intervals. However, some of these flags can occur instantaneously, the informational flags, for example. You will see instantaneous flags also be passed up to the intervals that are stored so that you know what was happening on the data for each scan that it was doing in order to build up its average. I'll pause there for just a moment to see if there are any questions on that. before we move away from instantaneous flags. If not, we can move on. Again, if you have questions I missed, we'll get them at the end. Instantaneous versus averages. The validation flags are applied to the instantaneous data. They get propagated up to what we call the base extended 1 and extended 2. In the data controller, our channels always have 3 average intervals, the base extended 1 and extended 2. And those get propagated up, the instantaneous ones, due to those intervals. These are the intervals that are stored, the base extended 1 and extended 2. That's for any part 75 valid channel, a 1 minute, 15 minute, and 1 hour. That's defined by the regulation, what those intervals need to be. Average validation flags are applied to these intervals. They don't get passed up to other intervals. They are specific to the interval at which they are applied. A H flag, for example, is a high limit flag, and a high limit interval on 1 minute would not be applied to the subsequent 15 minute. You would also compare your 15-minute value to a different limit to compare it to see if you were over the limit. Instantaneous validation flags cannot be turned off. They validate in the data controller. However, you can use flags to mark data invalid using masks in StackVision. And I'll show that in just a moment. But first, let me talk a little bit about flag propagation. So this is directly from the 8864 user guide and reference manual. Shows how data validation flags are propagated. Actually, I think this is not from the data controller manual. This is from a little bit older reference. It's the yellow and red tables from the EMR manuals, but this still applies in the data controller. You can see how instantaneous validation flags in MathPack versus average MathPack channels. Instantaneous validation flags on a math parameter get passed up through all of the averages. You can see this is a math channel and M-type channel. And again, I'll leave this to reference to look back to if you have a question about how a flag gets propagated. I don't want to dig too deep into the details on some of these topics. But you can see for an average MathPack channel, one thing that's interesting is that the instantaneous reading configured on a MathPack channel does show up, for example, a B or an F flag. But you can tell by the little asterisk here, it does not invalidate the data. So one thing to remember is that M-type channels validate their data based on their flags. M-type channels are vertical math, meaning that a 1 minute average for an M-type channel is built from all of the scans during that minute. Whereas a P-type channel is horizontal math, and all of the average for a P-type 1 minute average is the value from all of the 1 minute constituents. And so P-type channels get their validity from their constituents. So you can configure one of those instantaneous validation flags I was talking about that are configured with digitals on P-type channels, and they will show up, but they will not change the validity of that P-type channel. And I'll show that a little bit more here in a moment. Instantaneous validation and the V2C flags show up on the instantaneous readings and are propagated to the other intervals. And they're also propagated downstream if it's used as a constituent. With the new flag passing options introduced in the new 6.00 firmware, you can control what flags are passed or not to subsequent constituents. And you can find more details about that in the presentation we did earlier this year for the 8864 update. Out of control is the same way. It does an instantaneous reading, propagates to the intervals, and gets propagated downstream to any other constituents that are using that parameter. Average flags propagation. So all average validation flags on math parameters appear on the individual interval in which they are configured, but they do not get propagated. So for example, an H flag on a COPPM 1 minute only applies to that parameter. It does not get propagated to a downstream CO pounds per hour parameter. So some flags propagate, some don't. If you look back to that propagation table that I showed, you'll be able to see there how the flags are propagated. So that brings us to our first tips and tricks. how math channels get validity from their flags. Now, I mentioned this already, but now we'll go into a little more detail. Math channels get their validity from their flags. These are M-type channels, meaning that if you have a 1 minute base average, it'll do approximately a scan per second, gather up those 60 scans, compute an average from those 60 scans. So if it's a math channel of A plus B, it'll do A plus B 60 times. And then it'll take the average of all of those numbers to give you a value for the 1 minute. And it will use flags configured on itself. That's this line, flags configured on the math channel, and any flags from constituents. If there were flags on A or if there were flags on B, it'll use those as well. Average math channels get their validity from their constituents' validity. So for an average math channel, instantaneously, it will still do A plus B 60 times to show you an instantaneous value on the screen. However, it doesn't use any of that data for its 1 minute average. All of that data is just thrown away. When it's time to calculate the 1 minute average at the end of the minute, the P-type channel will look at its constituents and say, what are your values? And it will calculate a value right then based off what the constituents determine their values to be for their 1 minute averages. Average math channels will have flags configured on their averages show up, but they don't affect the validity. However, they do show up. And flags configured on average math constituents also show up, but they don't affect, well, they do affect the validity. The flags configured on average math constituents, the validity of the P-type average math channel is based on the validity of the constituents, not the flags on the constituents. So this is accurate, but a little confusing. The validity of the constituents is what decides the validity of the P-type channel. If any of the constituents in a P-type math channel are invalid at the 1 minute level, then the 1 minute value will be invalid. So let me show you an example of that. And this is a one where we can spend a little bit of time on explaining if we need to, or if somebody wants to go over this in more detail later, we can set up a call. But let me set up the stage for you here. Suppose we have a math channel with 100% validity on the base. That is your default. The equation is offline plus BAD. You can see I've got two different parameters here. Offline parameter, math parameter, an average math parameter, and a BAD parameter. So I've got an offline parameter who's controlled by, well, an F flag can go on this parameter based on a pseudo bit. I've got a BAD parameter that can also be controlled by a pseudo bit to put a flag on him. And again, this is some of the more in-depth stuff. I'm assuming that everybody understands how to apply these flags using digitals. I've got a math and an average math channel. Both of them have the equation of offline plus BAD. So the math is 100% validity on the base. The average math has an offline F flag of 34. So I'm saying if 34 is true, put an F flag on average math. Okay, 34 is true, put a flag on. Equation is offline plus BAD. BAD has BAD status equal 33 equals 0. This is a typical configuration that you would see in the field where an analyzer would be sending a digital bit as long as it's good. That way, if something goes wrong with the analyzer, it's no longer sending the bit, something's bad. So it's a normally closed signal, meaning that when 33 goes to 0, we have a bad status. So BAD will be good so long as 33 is closed. If 33 opens, BAD will be bad. 100% validity on, or excuse me, 1% validity on the base, which means I only need a single scan in the entire minute for the minute to be valid. All of these have default 1 minute, 15 minute, 1 hour intervals to make it simple. Offline is my offline channel. He has an F flag configured of 34 equals 0. If 34 is 0, he will have an F flag. Notice he is the opposite F flag configuration of average math. Offline has 34 equals 0, average math has 34. So now let's see if we can make this work. Let me take off my laser pointer. And let's speed it up a little bit. So you can see starting off, we're at 8:59 and about 8:59:52, I opened the bad status bit, okay? So the minute was good up until this moment. At this moment, I opened the bad status bit, which made 33 go to 0. That gives me a B flag on my math channel. A B flag on my bad channel. Remember, the B channel was configured on the bad, so it initially showed up here and then propagated to both the average math and the math. Now, this is instantaneous data. This is second by second. This is real-time engineering with flags. Over here, I'm showing the last base average. So this is the 1 minute interval that was recorded for minute 58. We're getting ready to record minute 59 because we're inside of minute 59. My offline signal is still good. Remember, math and average math have equations of offline plus bad. So we now have bad statuses on bad, which is propagating to average math and math both. And we can see the input line history that 33 went from 1 to 0 at second 52. So now if we go forward a little bit more, cross the minute, now we can see the effect that having that bad status on 8 seconds of the minute has on the 1 minute data. Again, here's the 1 minute data. It just rolled over. This is the last 1 minute data that was calculated. Because we had a B flag inside the minute for bad, the B flag shows up. However, he's got 1% validity. And because we had some scans that were good before that B flag showed up, we get the greater than flag. It means that we had some invalid data, but most of our data was good. Average math, same situation. It gets the flags that are on the constituents, greater than and B. You can see that the F flag is still showing up instantaneously on the average math because the 34 is still set to 1. But on our interval, we get the flags from the constituents. The constituents decide the validity. On the math channel, we have less than and B. This one has 100% validity. Now, he got the B flag for the same 8 seconds that average math got that bad got the B flag. Remember, offline is good, so offline doesn't play into the validity for any of these three right now. The validity for bad and math you would expect to be the same. However, bad is configured with a 1% validity on the base average, and because there was a single second where it was good, it got a greater than flag. Math is configured with 100% validity. And so because not every scan was valid, we get a less than and an invalid 1 minute interval for the math channel. Now, let me continue a little bit further and show you a little bit more. If we keep going, now, this minute 01, I didn't change any of the input bits. So for this minute, there was a B flag on every scan of the bad channel. You see, we crossed the minute interval and it created a new average. Because every scan had a B flag, it's now also invalid. And we get a less than in B that propagates to average math. Of course, the math channel didn't change because he was already invalid. And what I'm really trying to illustrate here is the difference between math and average math channels in propagation. And so you can see we're inside minute 01 and about 01:13, I took the online signal away. Now, as soon as I did that, you can see average math still has the F flag because it's now being propagated to him from the offline channel. He no longer has the F flag because it's configured on him, but his constituent is now propagating it in. And so now we can see that instantaneously we have the F flag coming from the offline channel, cascading to the math and the average math channel. And if we go forward just a little bit more to get past this minute, so now we're in minute 01, so we need to go right past the top of the minute to see how that's going to affect our next average. We want to be right here. You can see that now offline, because it also had a 100% validity by default, had some invalid data because of the F flag, will be marked less than an F. Math will be less than F and B from his constituents, average math also less than F and B from the constituents, and bad less than and B from the constituents. And if we close them both back, take away the bad status and the online and let it roll over again, you can see that only bad goes good here because we still had some invalid data inside the minute that our offline is now propagating the bad status to both math and average math. And so you can see that flag propagation is not as simple as what is on a constituent. You also have to take into consideration what channel type the constituent is going into. So there's a lot that has to be considered when determining flag propagation. I'll pause here for a minute to see if anybody has any questions regarding this. I know that's a lot to take in, but feel free to review this at your own leisure. You can even set up a similar configuration. These are the only settings you would need to change, shown right here, to test this out yourself and see how it works. All other settings would be default. You actually don't even have to set the 100% validity on the base. That will be there by default. Okay, got a lot to cover, so I'm going to start moving really fast through some of these other slides because I'd like to get to some of the more interesting stuff at the end. I do have some other slides in here that talk about channel types, but I'm just going to breeze by those. Those are in here for reference. So real quick, the flag validation overrides. Here's the thing in Stack Studio where you can configure a flag when it's pulled to give you a mask. So here are the flags here. If you pull a B flag, give it an out of control mask. Please don't ever do that. This is not a good example. That is something you would never want it to do. If you see that in your configuration, you've probably got problems. Typically, engineering standard will be that the T flag will have that mask, that if we pull a T flag, we'll give the out of control mask. And in fact, that has to be there to correctly mark out of control data as it's pulled. Here's the instantaneous flag readings, which I was just showing to you. You can get to this from the home menu by hitting DF, Delta Frank. This will display the readings in real time with the flags. Here's the other screen we were looking at in that previous example. This is the real-time engineering flags on the light space average. That's Delta Bravo from the home menu, DB, Delta Bravo. And now we'll start talking about some channel types real quick. Most cases, you'll want to see your A and your Q type channels. Those are your raw inputs. All of those should have a B, M, and an F, and a plus and a minus, or maybe even some custom flag conditions somewhere. Unless you really do have a raw channel and you're passing that to a map channel and applying the flags there, at some level down at an M type channel or an A type channel. A type channels calculate their data a lot the same way that M type channels do. The Q are the same way, whereas they do basically like averaging. They do vertical math essentially. You'll want to see somewhere on an A, a Q, or an M these flags applied. You wouldn't want to see these applied at a base level P type channel because then you're not going to get the expected results because these will not put validity on a P type channel. Typically, these would not be configured on a P type channel. J and M are also another place where those can be configured instead of putting them on the raw. There's different reasons for doing or not doing that. And analog outputs can be affected by flags as well. There's a field called action when flagged, when if you get a certain flag, you can control in one of these 4 modes what you're going to do with your analog output, whether you're going to hold it, go to a low value, ignore it, or zero it. And so that's flags. I'm going to move on to channel types. And here's just a quick overview. Again, as you can see, there are a lot of channel types. So there's a lot of documentation and there's a lot to go into. And the information and the amount, it can be overwhelming when viewed at such a high level. So channels are where we process and store data in the controller, typically 3 time intervals. And that's really because of the Part 75 regs and the way that the validation needs to take place. And they can trigger alarms based on values or conditions. Parameters are what exist in the server side in StackVision and Data Lab. A parameter gets its data from a channel. And you can have a parameter without a channel in StackVision that's calculated some other way at the server side only, but you can't have a channel without a parameter. I mean, actually you can, but there's no way to configure it in StackVision and get it downloaded into the controller. So tips and tricks. This is the main channel types. Most of your configurations can do everything you need to do with these, 7 channel types? Your standard averaging and your merge to get your raw values, your math to condition them to apply scaling factors, counter channels to handle your complex logic and your permit conditions, average math pack to handle Part 75 requirements for determining compliance in real time at the data controller. Modbus channels for handling communication between analyzers, and multi-conditional time online channels to control time online, offline. So, channel types. Like I said, I'm going to breeze through these slides pretty quick to leave times for discussion at the end. This is the most commonly used. It would tie to an analog input card or a voltage input card. You can come back and look at some of these. There's some indications of what current input and voltage input looks like and how to add that type in Stack Studio and where you would do that. Modbus channels are for communicating with Modbus, either Ethernet or serial, most often used for communicating with an analyzer, and allows you to use scaling factors, either intervals or float, depending upon the analyzer that you're dealing with. Again, if you have questions on these, we can circle back later or just get with me after the presentation. Merge channels, these are really designed for analyzers where you got a high range and a low range. You know, at startup, a lot of times you'll have a very high value, and so you'll need a high range in order to be able to chop that up with the A to D converter to get good resolution. But then in your normal operation, you'll have a much smaller value, and you don't want to have that resolution split across 200 when you need to measure in the 10 range. You're not going to get good resolution down in that 10 range. So a lot of analyzers will have a high range and a low range, and this is how we handle that in the data controllers. Math channels are your basic channels for doing conditioning to an analog signal. They calculate the same way that a type A standard averaging channel does, but they allow you to perform math on them. And also to change propagation of flags for the constituents that go into them if you need to combine gas flows, or if you just need to multiply something up by 10 as it comes from the analyzer. So those are sort of your raw channels. Interval math are the ones that are for Part 75 reporting specifically, and more Part 60 as well. They're based on intervals. They use it's required for calculated Part 75 parameters per the regulations. The EPA checks and ECMPS actually do that type of math. And you can see different settings that can be applied to each of the averaging examples. And so there's more examples here. Again, all of this is in the presentation for documentation after the fact. Another good slide you might want to spend some time looking at to understand how M-type channels and P-type channels propagate their values versus a NOx, a flow, and a mass, the way that the NOx and the flow and the mass get their values at their, and it shows you instantaneous, then it shows you 1 minute, 15 minute, 1 hour. These are the three intervals down here. 1 second is your instantaneous, and it shows how those propagate. You can see with an M-type channel that your NOx and your flow at the instantaneous level would propagate to a mass at the instantaneous level, but then that would propagate up to the mass at the 1 hour. And so there's that vertical math that I was talking about. Over here, you can see that you would get a 1 hour value here and a 1 hour value here, and that they would propagate over to the 1 hour value here. That's that horizontal math that I was mentioning. Okay, T and U channels are for your time online conditions, either based on a value of a parameter or a digital input. And your counter channels, these can be used as flip-flops. They can be used as accumulators. Counter channel is really very powerful and can do a lot of the functionality that we used to have to do with home-baked counter channels using constants and math equations, constructs, and rolling average channels to accumulate things. Counter channel can really take the place of all of that. You can do averages or counters with them. And so counter channel is something that I encourage you all to look into. We've redone a lot of things in some systems using counter channels instead of the older ways of doing things, and it really just makes it a lot easier to handle, much more straightforward. Okay, so that brings us to the end of the channels. So we're 2/3 of the way there, which is good because I want to end early so we have time for questions and discussion. So to solve communications issues with the 8864 data controller, there's really five steps involved. First, you have to know what your settings are, what your IP address is, your subnet mask, your gateway. You need to know what they should be and what they are configured in the data controller. You also need to know your local network topology. You know, are there routes or firewalls that need to be taken into account? Is there network address translation taking place? These sorts of things. Then we've got some tools to help you out. Does the data controller respond to ping requests if you're allowed to do that on your network? And can the controller ping out? There's a menu in the data controller that allows you to ping from the data controller out to try and make sure that you have connectivity. And there are some TCP tables that can give you additional information. And this is getting to the really low level of network debug, which we don't often have the ability actually to do at a lot of these sites, including the TCP/IP or Modbus capture. If you get to that point, you know, what does a TCP/IP trace show? And a lot of times we're unable to run Wireshark on the servers in order to get that sort of information. But if we can get that, it really is extremely beneficial to resolving some of the issues that we're unable to solve otherwise. And so here's a screenshot of the settings in the data controller for Ethernet configuration. So from the home menu, you would go to your configuration system Ethernet. So that's Charlie Sierra Echo. And that would take you to this screen. And from this screen, you can see what the IP address, you can configure your IP address, your mask, and your gateway. And you can also see what's currently being used. Just because you have it configured, you know, have you got some sort of problem where something is hung up the Ethernet port and you need to reboot? You know, I've seen it happen occasionally where you'll have an IP address configured here, but this will be all zeros down here. And there are different reasons why that can happen. And it's built into the protocol, actually. So you'll want to come in here and see what address you have in use. And so there you can tell what your settings are that are currently being used. And your network topology. You know, this is something you can get from your IT department. You know, are there firewalls involved? Do you have a situation where you're using two different networks, one for your business and network and one for your on-site network there, one for your controls network? And if so, how are those separated? You know, are you required to configure static routes in the data controller so that you can actually route to the correct place going out the gateway? So these are all things that need to be taken into consideration if you're having communications issues, to make sure that you're the people that set the network up there are involved, so we can understand what topology we're dealing with, so we can get you the correct settings set up. And can you ping out? So here's some of the tools that we have available. From the home menu, it's Sierra Papa status system ping. And then you can type in an IP address and start the ping. It'll try 3 attempts and report back to you whether it was successful or not. TCP tables. Well, here's a table. If you ever wondered, this is what they mean. And you can come back to this for reference. This is a good handy reference. So when you go in there, these are all actually from the protocol, and that's what the data controller reports on that screen. There is no enumeration in the data controller which says, say this. It actually comes from the IP packet itself. It just directly reports what's in there, and these are the states that can be in that status. So you'll want to look to here to know what's going on. So if you see send sent, you'll see that we're waiting for an acknowledgement from the remote endpoint. We sent a connection request. This is the step 1 of the three-way TCP handshake. So this is basically step 1. We never got past that. We're just sitting there waiting. So that's a good reference to have. And here you can see sort of a flowchart diagram. And I got this from IBM support website. It just sort of shows the flow of a TCP/IP communication path. And you can see send sent is one of the first things that happens. Once we get that send ACK back, then we send another ACK and we are established. But we never got that send ACK back. So send sent is essentially the first step. So here's the starting point, step 1. If we never get past this, nothing ever happens. And this is for an outbound connection, as opposed to if we have a port listening for something, we'd be in the listen state. So we'll go to one of these 2 states first, and then we'll go to one of these other states. And so you can sort of follow the chart here to see where you are at in the connection. And this can help you debug and figure out what's going on. Hey, have I got a problem with the Modbus configuration that I'm sending, or do I actually have a network problem? This can help you determine that. That's it for TCP tables. TCP/IP capture. We talk about Wireshark. This is a screenshot from Wireshark documentation. It just shows you all the IPs on a adapter that it sees, all the network and all the traffic. And we can filter through this and look at sources and destinations, and we can even see what's going across the wire for Modbus. We can dig into the packet and start to understand if we've got a problem. We've had to use this before for things like Modbus communication, where the words were coming across in a different order than we expected with byte swaps or something like that. This can help us get to the bottom of those types of problems if we don't have the documentation, which 9 times out of 10 we don't. So a very handy tool to keep in mind. And Modbus capture, another tips and tricks slide. So from the home menu, if you go status India Mike, that's status view Modbus TCP dump, you can actually view a TCP dump of Modbus commands. Now this is Modbus only, but it will show you a TCP dump of Modbus commands so that you can get an indication of what Modbus you're sending out. If you don't know if your communication command is going out correctly, or if you're not sure if you're getting a command into you for a response, you can look here and you can actually see inbound requests for data. And so that'll help you determine if you've just got something configured wrong in the data controller, if it's not responding, or if your maps are set up incorrectly or something like that. So this is a very powerful tool that you can use to help debug Modbus issues right there at the data controller. And you can actually even tell it to record it to a file, and then you can retrieve it from FTP, and you can open that file inside of Wireshark and start to dig through it and dig into it. So it's a very handy tool to have when debugging Modbus issues at a very deep level. And the rest is up to you. So that's it. That's all I've got to cover today. I wanted to leave these last 15 minutes for questions that y'all might have, or a specific topic that we can go back to and dig into a little bit deeper. I really wanted to give you all the opportunity to control some of the flow of the information delivered here. You can see my contact information there. If there's a question that you don't want to present here and you'd like to take offline, or any thoughts or ideas you have on the data controller, be happy to let you know. Just reach out to me. The slides and the presentation will be available after this presentation, so you can review them. And in your review, if you find something that you want to discuss, feel free to reach out. If I'm not available, just leave me a message. I'll get back to you as quick as I can. Be happy to set up some time to go over any of this with anybody that needs to. Thank you all for your time. We'll go ahead and end it there.